Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Level 50, knowing that the shaded area is equal to 6,000 millimeters square and that its moment of inertia with respect to AA prime axis is 18 times 10 to the 6 mm to the fourth. Determine its moment of inertia with respect to BB prime for D sub 1 equals 50 mm and D sub 2 equals 10 mm. So for our solution, let's have input the data D1 50 mm, D sub 2 10 mm. So moment of inertia with respect to the axis BB prime is moment of inertia through the centroid parallel to BB prime. So I'll call that IC, I sub C, then plus area, which is given 6,000 distance square. So the distance between that axis there through the centroid and the axis through BB prime. And that distance is D sub 1 plus D sub 2 or 50 plus 10 quantity square. So I sub BB prime equals I sub C plus area D sub 1 plus D sub 2 quantity square. Likewise, the moment of inertia with respect to the axis CC prime is moment of inertia with respect to the centroid parallel to that axis I sub C plus area D sub 1 square. So IAA prime equals I sub C plus area D sub 1 square. So substitute into this equation because the moment of inertia with respect to AA prime is given 18 times 10 to the 6 and area is also given 6,000 as well as D sub 1. So to compute for I sub C. So 18 times 10 to the 6 equals I sub C plus 6,000 times 50 square. So I sub C can now be computed. It is equal to 3 times 10 to the 6 mm to the fourth. Then substitute into this equation here. IBB prime equals 3 times 10 to the 6 plus 6,000 quantity 50 plus 10 quantity square. So from here we can now compute IBB prime. IBB prime is equal to 24.6 times 10 to the 6 mm to the fourth. Level 51, the moment of inertia of the area A about the parallel P and P prime axis differ by 15 times 10 to the 6 millimeter to the fourth. Compute the area A which has its centroid at C. So since axis P parallel to the axis through the centroid is farther than the axis through axis P prime, therefore the moment of inertia with respect to axis P is greater than that of the moment of inertia of area with respect to axis P prime. So that is I sub B minus I sub B prime equals 15 times 10 to the 6. So that's our working equation for our solution. I sub B minus I sub B prime equals 15 times 10 to the 6. Where I sub B is equal to I sub B is equal to I sub C plus area 75 square. I sub B prime is I sub C plus area times 50 square. So I sub B equals I sub C plus area 75 square, while I sub B prime equals I sub C plus area 50 square. So if we're going to subtract this second equation from this equation here, then take note that I sub B minus I sub B prime is 15 times 10 to the 6. We can cancel I sub C. Then we have area quantity 75 square minus 50 square. So subtracting 15 times 10 to the 6 equals area quantity 75 square minus 50 square. We can now compute the area, and the area is 4,800 mm square. Level 52, the properties of the plane region are polar moment of inertia with respect to the centroid, 1000 inches to the fourth, Ix 7000 inches to the fourth, and Iy 4000 inches to the fourth. Here is the given figure. Calculate the area, the moment of inertia with respect to the centroidal x-axis, moment of inertia with respect to the centroidal y-axis for the region. So for our solution, let's set up Ix. Ix is equal to Icx plus area distance square, which is Yg square, 16 square in this case. Ix equals Icx plus area Yg square. Ix is known, so we can establish the first equation. We have two unknowns here, Icx and area. Then for Iy, we have two unknowns again, Icy and area. Then if we reinforce the third condition that G sub GC is 1000 and 1000 is Icx plus Icy, adding the equations established, then we can compute the area first. And from there, we can solve Icx and Icy. So substitute here, Icx 7000 equals Icx plus area times 16 square. Call that equation 1. Then Iy equals Icy plus area 12 square, because the distance between the centroidal axis and the y-axis, which are parallel, is 12. So 4000 Iy equals Icy plus area xg square. So 4000 equals Icy plus area times 12 square. Call that equation 2. Then let's reinforce this. J sub GC is 1000 and it is Icx plus Icy. Icx plus Icy. So if we add equations 1 and 2, 7000 plus 4000, which is 11000, equals Icx plus Icy, which is 1000, plus area 16 square plus area 12 square. So we can now compute the area. So 7000 plus 4000 equals 1000 plus area 16 square plus area 12 square, or area quantity 16 square plus 12 square. This 1000 here is Icx plus Icy, because we add equations 1 and 2. So from there we can solve for the area, 25 inches square, or square inches. Then substitute in equation 1 to solve for Icx. 7000 equals Icx plus 25 times 16 square. So Icx is equal to 600 inches to the fourth. Then into equation 2 to solve for Icy, 4000 equals Icy plus 25 times 12 square. So Icy is equal to 400 inches to the fourth. Level 53, determine the moment of inertia of the cross-sectional area of the T-beam with respect to the x' axis passing through the centroid of the cross-section. So here is the given figure. This x' axis is also the centroidal centroidal x-axis of the T-beam, T section. So this distance, that's why this distance is denoted by barred y or yg in the figure. So let's divide the area into two parts. So this area here and this lower area here. So the centroid of the upper area, let's call the area as area 1, the lower area as area 2. But they are identical because 30 times 150 is equal to 30 times 150 also. So this is the centroid of area 1, and its centroid is from the base, from the bottom is half of 150, 75 plus 30, so that's 105 mm as indicated, labeled in the figure. The centroid of area 2 is here, so of course its distance from the base, from the bottom, is half of 30, 15 mm as shown in the figure. So this is the centroidal axis, so I'll call that G also, so that Ix prime is Igx and the distance is Yg. from the bottom. So area equals area 1 plus area 2, and area 1 equals area 2 equals 30 times 150 as shown, or 150 times 30, so it is equal to 4,500 mm square. The total area therefore is times 2 of 4,500, so 9,000 mm square. So let's transfer the centroidal moment of inertia of area 1, which is here, to the moment to the centroidal x-axis of the entire region, or x prime axis. So we need this distance here. So we need to solve for yg by Brigdon's theorem. 9,000 times yg equals 4,500 times 105 plus 4,500 times 15. So yg is equal to 60 mm. So if yg is 60 mm, 105 minus 60, so this distance is 45 as indicated in the figure. And since yg is 60 and this is 15, 60 minus 15, the distance between the centroidal axis of area 2 and the centroidal axis of the entire section is also 45. 60 minus 15 is 45. So that is Ix or Igx or Ix prime equals 30 times 150 cube over 12 plus 4,500 times 45 square for this upper rectangle. Moment of inertia with respect to the centroidal x-axis is base 30, height 150 cube over 12. Remember, with respect to the centroid, plus area of the rectangle, area 1, 4,500 times the distance between the parallel axis. So this axis here and the centroidal x-axis of the entire region, which is 45. Anyway, it is already labeled in the figure. Then plus moment of inertia of this figure with respect to the centroidal axis, 150 times 30 cube over 12 plus area, which is also 4,500. Distance is also 45, but quantity squared. So 150 times 30 cube over 12 plus 4,500 times 45 square. So combining, Igx or Ix prime equals 27 times 10 to the 6 mm to the fourth. Another way is, because Yg has been found, we divide the area into two parts. So let's extend this so that we only need to compute moment of inertia with respect to the base of two rectangles with respect to the base. So this dimension less this dimension is 150 minus 30 for these two with respect to the base. Then we have another rectangle with respect to the base with dimension is 30 mm by 180 mm, 30 plus 150. So I'm not showing it here, but because I explained it, as you should be able to follow, let's extend this so that we have two rectangles whose bases are coincident with the bottom base, so that the moment of inertia with respect to the bottom base is simply base height cube over 3. So IB equals Ix prime plus area Yg square. So we need to solve for IB. 150 minus 30 times 30 cube over 3 for this wing rectangles. These wing rectangles, 150 mm minus 30. So we will not include this because this is part of this rectangle here. So for these two wing rectangles combined, the base is 150 minus 30 times height 30 cube, then over 3 because it is with respect to the base, plus the moment of inertia of this rectangle with respect to the base is 30 180 cube over 3. So 30 180, where 180 is 30 plus 150, quantity cube over 3. So that's I sub v equals ix prime to be computed and verify that it is equal to this plus area, which is 9,000, then yg squared because the distance between the centroidal axis or x prime axis and the base is yg or 60 squared. So equals ix prime plus area 9,000 times 60 square. So if you compute for ix prime, it should be the same as 27 times 10 to the 6. So if compute combining these two, and this is 32.4 times 10 to the 6. So ix prime is also igx is 27 times 10 to the 6 mm to the 4th.